Hi guys. Let's talk about exact, okay? So some of you understand about the concept of exact well, or like it was not easy to understand, right? Because this one is based on the calculus 3 material, okay? So I'm gonna try to explain this one as easy as possible, okay? So okay, here we go. So like there's like some statement about like the concept of exact, but like let me try to explain a little bit more easier way. Okay, first of all, this is working for first order nonlinear equation. Okay, so let's do it. Okay, here we go. So let me rewrite your differential equation first. It is simply written by m plus n y prime equals 0. Okay, or like you should better to write this one instead, dy dx instead. Okay, so well, I believe you learned about partial derivative like from calculus 3, right? So let me stay here. Okay, partial derivative of psi, okay? Then what is that? We notate by d psi, okay? That is equal to d psi of dx, because like in psi, we assume psi is the function of x and y, and then plus, actually there is like dx dx as well. Dx over dx equal to 1, that's why we don't have to write the one. And the next one is d psi dy times dy dx, okay? So just compare with your differential equation and the like partial derivative, okay? Can you find it? It's definitely your m, if your m is equal to psi y, dy, d psi over dx, and that's really good like combination, right? And if your n is equal to d psi over dy, then your differential equation, we can say your differential equation is in terms of the partial differential equation, okay? Let me rewrite this one, okay? Here we go. So yeah, we can say m is psi x. You know this notation, right? D psi over dx can be written by psi x simply, okay? And this guy can be written by n is equal to psi y, right? So let's take the derivative one more time, okay? For psi x, we're going to take the derivative with respect to y. Then this guy can be written by my is equal to psi xy. And the second one is, let me take the derivative with respect to x, okay? Then nx equal to psi yx. Is it okay? And you have to remember, if psi xy and psi yx are continuous function, then psi xy must be equal to psi yx. Do you understand what I'm saying? So look at that. I'm talking about psi xy and psi yx, okay? They must be equal to each other as long as they are continuous, okay? Which means your my must be equal to nx. You know what I'm saying, right? We would like to have your differential equation as the partial derivative form. To be the partial derivative form of psi function, then it must be satisfied this blue part, okay, which is my is equal to nx. Is that okay? So keep that in mind. M and n's are given in the function, given in the equation. Then we're going to take the derivative with respect to y for n, and with respect to x for n. If they are equal to each other, we can say there exists some new function which is psi, which satisfies the partial derivative, okay? This is the idea of the exact, okay? So like to use exact, and we have to find psi function, but like, we're gonna start from checking it is exact equation or not, okay? How? We're gonna check this guy, my is equal to nx. You understand why it is my and nx, right? It is not mx and ny. Mx will be psi xx and ny will be psi yy. They cannot be equal to each other, okay? But like, like we know psi xy must be equal to psi yx. That's why it must be my is equal to nx. Is it okay? So this is the idea about the exact, okay? So like there's the theorem about this one, okay? As I told you, first we're gonna check this guy, my is equal to nx. Let me explain one more time, okay? This came from like, we have to find psi function, but it is equal to psi xy is equal to psi yx. Is it okay? So once it is true, then your differential equation, look at that. Let me rewrite your differential equation, okay? M plus n dy dx equal to 0 can be, keep that in mind, your right-hand side must be equal to 0, okay? Can be written by derivative of psi function. Is that okay? Then like the function which derivative equals 0, right? It is constant function, okay? So we know your solution of differential equation is psi is equal to constant c. That's it. This is the solution of your given exact differential equation, okay? So this is the idea, okay? So let me show you how we can use this idea for the example, okay? Here we go. Look at that, okay? So as you can see here, oh, there is a y squared term, okay? Well, let me make the parenthesis for first one. That is m. That is y squared term, which is nonlinear. And also, like this guy, 2 and 2xy, which is n term, and it's y times y prime is nonlinear term as well. Okay, both of them linear. So which is this is first order nonlinear differential equation. And unfortunately, this is not the separable. Then we should suspect like it could be exact. Okay, how can you check it? We assume there is some function psi which satisfies this equation. Okay, and to check that one, here we go. Here we go. Step one, check it is exact or not. Can you do it? We're going to do the my, set that equal to nx. Okay, if they are equal to each other, we're going to say there is psi function. Okay, so let me do it. Okay, my is equal to, we're going to take the derivative with respect to y for n, then 2x can be considered as constant, right? So 2x prime equals 0. Then we take the derivative for y squared only, right? Y squared prime is 2y. That's it. And what about nx? For this derivative, we're going to consider y as constant, right? So which means like 2xy can be written by 2yx, right? And take the derivative of like 2yx, it is 2y. Ooh, they equal to each other. Then we can say it is exact. Then we have to find your psi function, right? What was psi function again? We have to remember psi x is m, which is 2x plus y squared, and psi y is equal to n, right? Which is equal to 2xy. You can start from m or n, doesn't matter, okay? So either way, but like, for the practice, let me start from n first for this time, okay? For next example, I'm gonna start from n. Is that okay? So here we go. Since your n is psi y, we will take the derivative, take the integral with respect to y, okay? That will be the psi function, right? Here we go. Psi is equal to integral n dy, okay? So that is equal to integral n is 2xy and dy. Is that okay? Then look at that. We can consider 2x as the constant, right? So this can be written by 2x integral y dy. That's much easier than before, right? If you write like 2x in front of integral, right? Then it is equal to 2x times 1/2 y squared. And we normally add constant, right? But like, that will be not only constant, but also the function of x as well, because we consider x as constant for this derivative, right? So we should write f of x. This f of x includes the constant as well in there, okay? And that's it, okay? Let me simplify. That is equal to 2 canceled out and x y squared plus f of x. That is your psi function, okay? Then keep that in mind, we didn't use m yet, right? What is m? It is partial derivative with x, okay? Just like a psi y, psi x, right? Then we know psi x must be equal to m, okay? That is first term, right? And do that. The psi x is what? Take the derivative with respect to x, okay? X y squared prime, y squared is coefficient and x prime equal to 1, right? It is y squared plus f prime x, okay? That is definitely the derivative with respect to x, okay? Is equal to m, okay? Which is equal to 2x plus y squared. Just compare this, okay? Look at that. Your left-hand side, there is y squared. That's perfect. There is y squared as well on the right-hand side, okay? Then look at that. We can easily guess your f prime of x is x must be equal to 2x, right? Here we go. F prime x equal to x, okay? Then anti-derivative of this function is equal to x squared. Is that okay? Does make sense? Like there is constant, but we're gonna add constant at the end, okay? So now we can update your psi function. There we go. psi is equal to xy squared. I'm talking about this guy, right? We just update f of x, okay? Plus x squared, okay? Then there is plus c, but keep that in mind. That is equal to, as we just like talked in the theorem, and that is equal to constant is your solution of this differential equation, okay? This one is your solution of differential equation. Is that okay? So let me give you one more example, okay? Then you should understand much easier, okay? Here we go. What about next one? Look at that. First order nonlinear differential equation, okay? So we learned only two way to solve the first order nonlinear equation, right? This is, when you look at this one, it is totally not the separable, right? Then only one thing that you can apply is the exact, okay? So here we go. So this one is M, and this guy, which is in front of y prime, is N. Definitely your right hand side must be equal to 0, right? And then, okay, we're gonna check it is exact or not, right? How can we do it? We need to check my is equal to nx. I explained why it must be my equal to nx, right? Here we go. Then my is equal to cosine x is coefficient function for y, then it is cosine x. And then 2x e to the y prime is 2x e to the y. That's it, right? And then what about nx? Nx equal to sine prime is cosine. And for this case, e to the y is coefficient function, right? And we know x squared prime is 2x, right? It is 2 times e to the y x. Like, is it okay, like, to switch the order? Or like, we can just keep writing. I'm sorry about that. Let me just write this, okay? X squared prime is 2x, and e to the y is just coefficient, right? Minus 1 prime equals 0. Look at that. They are equal to each other. So we can say it is exact, okay? Then we have to try to find the psi function, right? Here we go. As you talked about it, psi x is m, which is equal to y cosine x plus 2x e to the y, and psi y is n, which is sine x plus x squared e to the y minus 1, right? And again, you can start from m or n, doesn't matter, okay? But since, like in the previous problem, we start from n, for this case, let me try to start from m, okay? So since your m is psi x, and we're going to take the integral with respect to x, right? Here we go. So your psi is integral m dx. Then that is equal to integral m is y cosine x plus 2x e to the y dx, right? But don't worry about this one. That is not the crazy one. It looks crazy, but like it's not that crazy, okay? Here we go. Because the first one is, it's kind of like y integral cosine x dx, right? And the second one is 2 e to the y integral x dx. That's it. Because like we can consider y as the, like, just like a number, right? Because this is like integral for x only, right? Then that is equal to y sine x. So you know about sine x, right? Integral cosine x is definitely sine x, positive sine x, okay? And then plus 2e to the y, and integral x is 1/2 x squared, and there is constant c, right? But keep that in mind, it's not only constant c, but it must be a function of y is as well. So we can say f of y. Again, f of y includes the like function of y's and constant as well, okay? That's it, okay? So this is your psi, and then let me simplify this one, okay? It is equal to y times sine x plus e to the y x squared and f of y. The next step is we're going to try to use second one, which is n, okay? How can we do it? We need to find psi y. Just take the derivative with respect to y, okay? And that is equal to y times sine x. Again, we're going to consider sine x as coefficient, right? Then y prime equal to 1, which is sine x, and plus the second one, x squared is coefficient, and it's the y prime is e to the y, okay? And f of y prime is f prime of y. Definitely, that is the derivative with respect to y, right? And we're going to set that equal to n, which is sine x plus x squared e to the y minus 1. Look at that. When you compare your left-hand side and right-hand side, sine x and x squared e to the y is in there, both of them, right? But only thing is -1. Then we can guess. your f prime y must be equal to -1. Is it clear? And then antiderivative, okay? F of y is minus y. There is constant, but it will be added at the end, like for the solution, right? So here we go. So finally, your psi xy is equal to, I'm talking about, okay? I'm talking about this guy here, right? And then y sine x plus e to the y times x squared, or like you can just like write different order, doesn't matter, okay? And minus y and plus c, and we're gonna move to the right hand side, which is equal to constant c. So this is the solution for this exact differential equation, okay? I hope like this video can help you to understand about exact, okay?